Hello everyone, in this video we are going to learn about independent events. If events A and B are independent, it means that the outcome of one event does not affect the outcome of the other. Then probability A given B is equals to PA and probability B given A is equals to PB. So probability A intersect B is equals to PA multiplied by PB. Example 1 is given PA and PB. We want to find probability A union B. If A and B are mutually exclusive, then PA union B is equals to PA plus PB only because PA intersect B is equals to 0. Then substitute the values and calculate the answer. If A and B are independent, then PA intersect B is equals to PA multiplied by PB. Calculate the answer for this one first, then find probability A union B. Substitute all the values and calculate the answer. For example 2, we define the event first. Let M be the event that the student studied mathematics, and let B the event that the student studied biology. There are 60 students in sixth form of a certain school means that it is the number of sample 60. Mathematics is studied by 27 of them. This means that the students who studied mathematics is 27. So, the probability is 27 over 60. Biology by 20, that's mean 20 students studied biology. So, the probability is 20 divided by 60. 22 students study neither mathematics nor biology. This means that they did not study either mathematics or biology. So, it is probability M union B prime, and the probability is equals to 22 over 60. Question A is find the probability that a randomly selected student studied both mathematics and biology. This means probability M intersect B. We know that probability M union B is equals to PM plus PB minus PM intersect B. We can get probability M intersect B from this formula. Substitute all the values where we know that PM union B is equals to 1 minus PM union B prime. And we get PM intersect B equals to 3 over 20. Question B is find the probability that a randomly selected student studies mathematics but does not study biology. This means probability M intersect B prime and it equals to PM minus PM intersect B. So substitute the values and solve for the answer. Example 3 is the probability of a worker to have job satisfaction is 0.85 if he or she is given a satisfactory bonus and 0.45 if not given a satisfactory bonus. It's found that 90% of the workers are given a satisfactory bonus. By using tree diagram, find the probability. So let's draw the tree diagram. From the sentence, the probability of a worker to have job satisfaction is 0.85. If he or she is given a satisfactory bonus, means that the satisfaction of the workers depends whether they are given bonus or not. So first we show the probability of the workers given bonus and not given bonus. It is given that 90% of the workers are given satisfactory bonus. So the probability the worker are not given bonus is 0.1. Because together the probability is 1. If the worker is given satisfactory bonus, the probability that he or she has job satisfaction is 0.85. So the probability that he or she still does not have job satisfaction is 0.15. If the worker is not given satisfactory bonus, the probability that he or she has job satisfaction is 0.45. So the probability that he or she does not have job satisfaction is 0.55. And the final outcomes are Bj, Bj prime, B prime J, and B prime J prime. To find these probabilities, we had to refer to the tree diagram. Question A is probability that a worker has job satisfaction is Pj, where it equals to probability Bj plus probability B prime J. For probability Bj, it is 0.9 multiplied by 0.85. For probability B prime J, it is 0.1 multiplied by 0.45. So the answer is 0.81. Question 3b is probability that a worker is not given a satisfactory bonus given he has job satisfaction. This is conditional probability B prime given J. It equals to PB prime intersect J divided by PJ. Probability B prime intersect J is 0.1 multiplied by 0.45. Probability J we can get from question A. So now, calculate for the answer. Question C is, a worker is not given a satisfactory bonus given he does not have job satisfaction. This is conditional probability B prime given J prime. It equals to probability B prime intersect J prime divided by PJ prime. Probability B prime intersect J prime is 0.1 multiplied by 0.55. Probability J prime is 1 minus PJ. So the answer is 11 over 38. Example 4 is, a total of 120 students in a private college rides 3 types of motorcycle, Chris, Suzuki, and Honda to campus. From the total, 75 riders are male. Out of 50 students who ride Chris, 30 are females. There are 30 males who ride Suzuki and 5 females who ride Honda. When it involves 2 variables like this, it is easier if we use the contingency table to represent the information given. A total of 120 students is the number of sample space written at the right bottom. 75 riders are male, so the total male is equals to 75. 50 students ride Chris. That's mean the total for Chris is 50. From the 50 students who ride Chris, 30 are females. This means that the intersection of Chris and female is 30. 30 males ride Suzuki. This is the intersection of male and Suzuki. 5 females ride Honda. And this is the intersection of female and Honda. Now we can complete this table. 50 minus 30 equals to 20. 75 minus 20 and 30 equals to 25. 25 plus 5 is equals to 30. 120 minus 50 and 30 equals to 40. 40 minus 30 equals to 10. 120 minus 75 equals to 45. Question A is probability that the student ride Chris or Suzuki. Means that it is the union of A and B. And it equals to PA plus PB minus PA intersect B. By using the table, PA is equals to 50 divided by 120, which means the total of Chris divided by the number of sample. PB is equals to 40 divided by 120, which means the number of Suzuki divided by the total sample. PA intersect B is 0 since there is no intersection between Chris and Suzuki. So the answer is 3 over 4. Question B is probability that the student is female or rides Suzuki. This means that probability F union B and it equals to PF plus PB minus PF intersect B. PF is equals to 45 over 120, which is the total female divided by the number of sample. PB is equals to 40 divided by 120. That's mean the total Suzuki divided by the number of sample. PF intersect B is 10 divided by 120. That's mean the number of female who ride Suzuki divided by the number of sample. The answer is 5 over 8. Question C is probability that the student rides Suzuki given that the student is female. This is a conditional probability B given F. And it equals to probability B intersect F divided by PF. Probability B intersect F is 10 divided by 120. Probability F is the total female divided by 120. And the answer is 2 over 9. Question D is probability that the student is a male who rides Suzuki or female who rides Chris, which means probability M intersect B plus with probability F intersect A. Probability M intersect B is equals to 30 over 120. Probability F intersect A is 30 over 120 and it equals to 1 over 2.